Okay, so now that we know the basic parent functions for the 6 trig functions, we're going to start transformations of these. We've done transformations before with other functions in the first semester. We just haven't done them with something like trig functions, which gets a little bit complicated with the pi's and everything else that we have going on at the radians there. So we're going to start and do this slowly. Our first transformation day, we're just going to start with 2 factors, a vertical stretch and shrink and a horizontal stretch and shrink. And if you notice here, we are not actually going to be transforming anything but the sine and the cosine function. We're not going to be trying to transform the tangent, cosecant, secant, or cotangent just because those get a little bit more difficult. So what we're going to do, we have 2 different factors to this. If you have an a value out front of either sine or cosine, that is your vertical stretch or shrink. What we're going to do with that is we're going to multiply all of your y values by a, whatever that happens to be. If you have a b value after the sine or after the cosine, but in front of your x or theta, whatever it happens to be, that is a horizontal stretch or shrink. And notice anytime, like what we've done before with transformations, anytime you're doing something to the x, you're doing the exact opposite of what it says. Okay, so you need to remember that one. We're doing the exact opposite. You're going to divide your x values by b instead. A has a particular name. It is called the amplitude of the function. If you studied these at all in physics, you may recognize that. That's basically the height of the wave function that we're working with. The b value has no particular name, but it's used to find the period of the function. Typically for sine and cosine, the period's 2 pi. If you factor in any constant b, you have to divide by b to get the new period of the function. Okay, so this isn't terribly complicated, but I will encourage you to be drawing your own tables for your sine and cosine function. I know there's tables given here, but I'll kind of show you what I'm talking about as we work through the examples. It's not too complicated to do this on your own today with just an a and a b value. But we're going to throw in next time a shift left, right, or up, down. And that's going to make life a little bit more complicated, and you may want to do this the way that I'm showing you today. So for question 1 here, we are going to graph the sine function. So first we care about what the function actually is that we are graphing, because that determines what table of values we use. And the reason I encourage you to do your own table is because I'm not going to be giving you any of this. You need to just be looking at this function that you're given and saying, okay, it's a sine function. My basic 5 points for a sine function are the point 0, 0, pi over 2 up 1, pi goes back to 0, 3 pi over 2 goes down to -1, and 2 pi goes back to 0. And those are always going to be your values for your sine function. So if you just know those and you can write them down, it makes life a whole lot easier. Now from the function that you've been given here, you are to identify your a value, because that tells you your amplitude here. Now, side note on amplitude, this is always positive. Okay, you never, whether your a value is negative or positive, you never make your amplitude itself negative. Your amplitude is always positive. Your b value, remember, helps you find the period of the function. The period is always 2 pi divided by b, which in this case is 2. So if I reduce that, 2 pi divided by 2 means the new period of this function is going to be pi. So that means basically it's taking your sine function and it's halving it, or it's squishing it in half to make it half as big as it was before. Now, if you remember what we talked about above, we said also with the a values, you multiply those by your y. Okay, and your b values, you divide your x's by b. So if I take those, I'm going to just take the a first and say, all right, if I multiply my x's each, or my y's each by 3, excuse me, it's going to change all of my y's to these numbers. Now, if I then go through all of my x's and I divide them by b, I have to be a little bit more careful with this, because dividing by 2 in terms of all of these fractions here is like the same as multiplying by a half. So 0 is pretty easy. 0 times a half is just 0. On the other hand, if I do the next one, I'm going to multiply this by a half. That is going to give me pi over 4. If I multiply pi by a half, that's going to give me pi over 2. If I multiply 3 pi over 2 by 1/2, it's going to give me 3 pi over 4. And if I multiply 2 pi by 1/2, it's going to cancel that out and leave me with pi. So in this case, we have now 5 new points to graph. My 0, 0 point hasn't changed. On the other hand, my pi over 2, 3 point, it was pi over 2, 1, has now changed to pi over 4, 3. Remember, pi over 4 is halfway between each of these if you need them. So pi over 4 now goes up to 3. So that's going to give me a dot up there. Pi over 2 now has a value at 0. And 3 pi over 4 is negative 3. And then last point you have is pi 0. Okay, we typically want to graph at least 1 or 2 rotations of this. So if I kind of just followed this pattern, we know then next to this it would continue doing the exact same thing. So if I'm just counting blocks here, I'm saying, all right, that's the same as the one before it. So I would go over 1.5 blocks up 3, over 1.5 blocks down to 0, over 1.5 blocks down to negative 3, and then at 2 pi I'd be back to 0. I could continue that backwards here and continue graphing the same function for the entire rotation between negative 2 pi and positive 2 pi, which is going to show me a sine graph that is taller than our typical sine graph, because if you remember, our sine graph usually only goes up to 1 and down to negative 1. So because of your 3, it's now extended up to 3 and down to negative 3. And it's also made more rotations or cycles of this happen in a smaller period of time. So where the period was 2 pi to fit one full cycle, now it's just pi. So we see a full cycle between here and here, another full cycle between pi and 2 pi. Every pi, you're going to see a full cycle. All right, so let's try this again with a cosine graph on the next page. So on the next page, now again, remember you're not getting your cosine values, so you're expected to just look at this and say, all right, it's a cosine function. That means I'm going to write down my points are 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0, and 2 pi goes back up to 1. From my A value here and my B value here, I identified the amplitude. Remember, amplitude goes with A, but even though this one says negative 2, my amplitude is always positive. The B helps us find the period. To find the period, we do 2 pi over B. Does 2 pi over 3 reduce? If not, that is the period of the function. So I go through and I do the exact same thing I did on the last one. I take each of my y's and I multiply them by negative 2. Notice you don't multiply them by the amplitude, you multiply them by the actual A value. So that gives me negative 2, 0, 2, 0, and negative 2. And then I divide my x's by b. But remember, dividing by 3 is the same as multiplying by a third. So 0 times a third is 0. If I actually multiply a third by pi over 2, it gives me pi over 6 in this case. If I multiply a third times pi, it gives me pi over 3. If I multiply a third times 3 pi over 2, the 3's will cancel, which will give me pi over 2. And then last but not least, 2 pi by a third gives me 2 pi over 3. Now notice these are going up by 1/6. So remember, when I graph this, I'm going to graph my first point at 0, negative 2. Pi over 6 is the next mark over, so that's right here at 0, which means pi over 3 is the next one up 2. And then pi over 2 is back down. And then back down to negative 2 is our last point. And because each of these is over one block up or down 2, I can continue graphing multiple cycles of this all the way out to 2 pi, negative 2 pi to show the full picture of what this looks like. So your pattern and your points should just help you finish out the graph from there. And so our cosine function would look like this, if I can connect the dots well. So there's lots of rotations here. Oops, and I missed something here at the end. I went back to 2 pi there. I don't want to do that. That should go here and back to a minimum. There we go. There's lots of rotations in this. You can fit one full rotation of your cosine function in between 0 right here and 2 pi over 3, which is the period of the function. So every 2 pi over 3, you're going to see a full rotation of that. All right, so we're just going to practice this once or twice more, mostly to show you there's a couple different b values that we can use. So if I see something in number 3, I'm going to give you a chance to try this one on your own, just because it's not too difficult. Just remember that, again, you're writing your own points down for a sine function. Sine is 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and 2 pi 0 again. And then when you are going through and you're using A to give me your amplitude, which is 4, and B to give you the period. Remember, the period is 2 pi divided by B. But we don't really divide by fractions, so instead of dividing by 1/2, that's like taking 2 pi and multiplying by 2. So that means the period of this function is actually 4 pi, which is longer than the typical sine function. So just like you multiplied by 2 to find the period of the function, when you divide by 1/2 in your x's, you're actually going to be multiplying them by 2. So take a minute, finish out your table and your graph, and then we'll compare our answers in just a minute. Now, I went back and did my table here, so you can see my points are 0, 0, pi 4, 2 pi 0, 3 pi negative 4, 4 pi 0. Now, what do you do in a situation like this? Because if I start graphing this, I don't necessarily have enough information to fully graph my points. Well, I can do one of two things. Number one, I can always cross out these labels and relabel them. In this case, I don't have to see a full rotation of this, and you'll see why. First off, because the distance between negative 2 pi and positive 2 pi is actually 4 pi, so you're going to see a full rotation in that. However, if I start graphing this, I have a point at 0, 0. I have a point at pi up 4. And then at 2 pi's, the last point I can graph goes down to back to 0 there. So when I'm trying to finish this, you could also think, well, if I continued 3 pi over to the right, then would be down negative 4. Well, if I follow this backwards, 3 pi is the same as negative pi. So I can graph a point down here at negative 4. And 4 pi is the same as negative 2 pi if I continued going backwards. So what you can do is go backwards into the negatives, which would then show you a full rotation of your, or a full cycle of your sine graph, which would look like this. So this is a spread out sine graph that has a larger amplitude as well. All right, so then the last question we're going to do together is over here, number 4. And on number 4 here, the reason we're doing this one is because if you notice, there's something different about your b value. Okay, your b value in this one has a pi in it. That's going to make life a little bit different. And if you notice, it'll kind of tip you off because you see the marks on your graph down here are different. They're not labeled by pi's. They're instead labeled 1, 2, 3, 4, 5, 6. And you'll see why in just a second. This is a cosine graph. So we're going to do our points are 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0, and 2 pi back to 1. My a value, negative 3, gives me my amplitude of 3. And I have to be careful with my b value here to do the period of the function. The period, we do 2 pi divided by b, or multiplied by the reciprocal of b. So the reciprocal of b is 4 over pi. If I think about 2 pi as over 1, what's going to happen to the pi's here? Well, the pi's are actually going to cancel. I'm going to have 2 times 4, which tells me the period of the function is actually 8. Okay, not anything with pi in it. So I'm still going to use that multiplying by 4 over pi when I go in here. And I'm going to multiply each of these by 4 over pi the whole way down, because that's multiplying by the reciprocal is the same as dividing by it. And we want to be careful with that to make sure we do it correctly. Notice I'm showing my work on most of these because that really helps me see what you're doing and if you know what you're doing. So if I go through and I multiply by the reciprocal, it gives me 0 there. The pi's cancel here, so 4 divided by 2 gives me 2. The pi's here cancel, which gives me 4. You can start to kind of see the pattern. 0, 2, 4. If you continue canceling, 4 times 3 is 12. Divided by 2 gives me 6. And you should probably already be able to guess that this one is 8. Then we also have to take care of our y's and multiply those by -3. Okay, and once I do that, I have my new points. So I have the point 0, -3, which I can draw all the way down here. 2, 0. I have the point 4, up 3. And I have the point 6 back to 0. I don't actually have the point to get over to 8, -3. You could kind of estimate where it is and go over here somewhere off to the side of your graph. But you could also just work backwards. We kind of now know that it's over 4 blocks up 3, so I can go left 4 blocks up 3 and reflect this backwards as well, which will give us enough to fill our graph and do a nice full cosine graph there. Okay. If you want to continue out to 8, you can there. All right, so your homework for this is not going to be a ton of problems. If you flip over to the next page, your worksheet transformations, we are going to do pages, I forget the page numbers here, but we're going to do 1 through, let me check how many there are, 1 through 5. We don't want to do this review reflection section at all. So you can just do 1 through 5. Make sure you draw tables out for these and actually work through what the points are, show your work on that, and graph the full graph left to right, not just one rotation of this as you go. You have a practice page to work on first with the substitute that you're going to turn in before you leave to make sure we know what we're doing. I've left a key to check that against, or you can check next to a neighbor. And then you'll have the rest of the time to either work on your homework or take the parent function quiz if you haven't taken that yet.